So at this point, you may be wondering, why all the hype around DAX? All of these calculated column formulas that we've been playing with so far, the basic date and time, the logicals, the text functions, they're all pretty intuitive, pretty straightforward, and remarkably consistent with their Excel versions as well. So now that we've covered those basics, some of those fundamentals, it's time to start exploring some more interesting DAX functions. We're going to talk about one called related now. And in this context, I'm going to show you how to use related as a calculated column. And then later in the section, we're going to revisit this related function by nesting it within a SUMX measure, which is a really cool, really powerful iterator function in DAX. So this is where things are going to start to get a little more interesting and start to pick up pretty quickly. So related is a very simple function on its own. It just returns related values in each row of a table based on a relationship with another table. So syntax-wise, it's as simple as it gets. You literally just point related to a column name in another table that contains the values you want to retrieve. Could be a product name column, could be a retail price column, a country column, whatever it might be, as long as a valid relationship exists to that table where you'd like to retrieve the values. So tip here, related works basically exactly like a VLOOKUP function. It uses that relationship between the tables, which we've defined by our primary and foreign keys, to just reach into another table and grab the values it needs and pull them into a new column of another table. But the thing is, it works like VLOOKUP, but it's even simpler than a VLOOKUP because we don't need to define the lookup value or the match type or those other arguments that we need to include if we were writing a lookup in Excel. And the reason we don't have to define a lookup value explicitly is because Power BI already knows what your lookup value is because it understands the connection between your two tables. And that's why all you have to do is input the column name. Whereas in Excel, you're essentially defining what your primary key is within the VLOOKUP function. So here with related, because we've done all our data modeling already, that step is not necessary. One other note about related, this function does require row context because it needs to pull the correct value for each row of the table. So you'll only see related being used either as a calculated column, which I'm going to show you now, or as part of an iterator function that's designed to cycle through tables row by row. Things like filter, SUMX, MAXX, etc. Now, pro tip here, you may be thinking, okay, this concept makes sense, but isn't this kind of going against the normalization standards where we said we don't want to create redundant data like this? And yes, you're correct. Related does technically create redundant data. So it's important not to go overboard with related. You don't want to use this function to kind of hack your way into a huge merged table, but using it strategically to make certain fields more accessible is a valid approach as long as you're not bumping against file size or capacity limitations. That said, in many cases, you can actually replace the calculated column version of related by nesting it within a measure like filter or SUMX. And I'm going to show you that with SUMX in the iterator lecture, which is a really interesting one. So with that, let's pop back into our AdventureWorks file and try adding a new calculated column using the related function. All right, so when you open up your AdventureWorks report, head to your data view, and let's navigate to our sales table here. Now you may be realizing that so far we've been pretty limited as far as the numerical kind of quantitative values that we're able to analyze here. Really order quantity and return quantity are the two most meaningful ones that we have access to right now, but we do have a means of creating many more interesting fields, and we're going to do that using related and using some of the measures that we'll talk about in the upcoming lectures. So for now, what I want to do is try to pull the retail price of these product keys into my sales table. And I can do that because related will allow me to access fields from any related table. And if we jump to our relationships view as a refresher, we know that sales has valid relationships to customer, to calendar, to territory, and to each of these product lookups as well. So what that means is that related is going to allow us to access any field from those lookup tables and pull it directly into a new column right here in my sales table. So that's what we're going to do here using retail price as an example. So let's right click, new column. Let's name the column retail price. You can add a space or not, up to you. And it's going to be as simple as, related, and then point to the column name. And remember, I'm going to point to that column that lives in a related table. So the table that I'm looking for is going to be the product lookup. And here I can kind of just arrow down to look through my list of fields in that product lookup table. And the one we want is product price. So let's tab it in, close the parenthesis. That's the only argument. So we press enter and we're good. So there you go. We've got retail price. Right now it's not formatted properly. We can fix that in the modeling tab here. And we've got our formatting options. Don't have to go to the query editor. We can format right here in our data view. So instead of general, let's go ahead and choose currency, English United States, and that looks good. So as a quick QA, if we want to make sure that these prices map up to the retail prices in the product table, one quick way to do that, we could use a matrix view in the report, or we could do something like sort our product key here, ascending. So 214 has a retail price of $34.99. It looks like 215 has a retail price of $33.64. And now if we actually jump to our product lookup table and sort the product key ascending as well, now we can just make that comparison. The first row is product key 214, $34.99, 215, $33.64. So it checks out. And that's a nice little way to just do a quick spot check and make sure that related function is working properly. So back to sales. Now remember, we've essentially just pasted this data or replicated this data in a new place. It's nothing brand new, but this will allow us to now create some interesting new fields. For example, revenue. Let's right click, add a new column, name this one revenue. And now that within this table, we have quantities, we have prices, price times quantity equals revenue. So it's as simple as just multiplying those two columns together. So AW sales retail price times AW sales order quantity. We can press enter, and there you go. We've got our revenue. Looks like these are all quantities of 1, so the revenue is just equal to the retail price. And we can do a similar kind of spot check here and sort our order quantities. Let's actually sort descending. And there you go, 3 orders of a product that costs $23.55 yields a revenue of $70.65. So that looks good. This all kind of checks out. Let's go ahead and just for the sake of being consistent, let's format revenue as the same currency format as well. So there you go. We've used the related function to basically reach into the product table, grab the retail price, and pull it into a new column right here in our sales table. And from there, we use the values in that column to create a brand new field called revenue. So from here, we're going to shift gears a bit into measure mode, start with some basic math and stats aggregator functions, and then dive into some of the filtering tools that really set DAX apart.